Physical Science, Chapter 28. This is PS 28.1. And Section 1 is all about Earth's atmosphere. The main idea is Earth's atmosphere can be divided into layers based on differences in composition and texture. So, most of you have been to a wedding or seen a fabulous birthday cake of some kind, Pinterest, Instagram, real life. And you will notice that there's different layers, and each of those layers has a different consistency or quote-unquote chemical makeup. Well, it's very much the same thing. So your essential questions for this section that will reflect quizzes and tests: what are the layers of the atmosphere? How is thermal energy transferred throughout the atmosphere? How do clouds form, and what processes are involved in the water cycle? Air isn't just oxygen, it's a mixture of gases. Nitrogen is the largest component with 78%, and oxygen is next with just 21% by volume. Most of the remaining 1% is argon and water vapor. The remaining portion is a mixture of trace gases, so called because they are present in such small amounts they're not really easy to measure. And you can see those right here. Cellular respiration by organisms produces water vapor and carbon dioxide. That's you and me. Photosynthetic organisms, plants, use carbon dioxide and produce almost all oxygen in the atmosphere. Carbon dioxide, otherwise known as CO2, concentrations increase during the spring and summer due to photosynthesis by the plants. In the fall and winter, it decreases. Microorganisms in swamps, rice paddies, and soil produce nitrogen and methane. Those microorganisms in the digestive tracts of animals such as termites, cows, and sheep produce methane. Earth's early atmosphere contained mostly hydrogen and helium.
When the Earth first formed, the solar system was a violent place. Giant hunks of rock, metal, and ice slammed into the Earth's surface. As material collided and fused, there was intense heat and pressure. Matter vaporized on impact, leaving puddles of magma. Many of the collisions released water vapor and other gases, which gradually formed a blanket of steam around the early Earth. This thickened over time, becoming the first atmosphere. Some of the lighter gases, like hydrogen, leaked into space, but the denser steam collected and had a greenhouse effect.
Don't forget, at any point you may get a pop quiz on something that has been included inside of my video.
Insulating, heating, and melting the surface of the planet. Over time, the Earth, in a process called differentiation, separated into layers and its crust cooled. Steam in the atmosphere collapsed and formed the oceans, covering much of the planet in chemical-rich waters. The young Earth settled down, but then something about the size of Mars is thought to have slammed into the planet, causing immense change. The two bodies coalesced and material was blasted outward. Debris from the impact formed a ring of matter that orbited the Earth and eventually became the Moon. The surface of the Earth became molten again from the intense heat, and the oceans reformed a steam atmosphere. When things finally cooled down again, the Earth's crust hardened, and steam settled back down to reform the oceans. The Moon stabilized the Earth's tilt and helped to regulate climate. We don't know a lot of specific details about events during the Hadean Eon. There may have been several large asteroid or comet impacts, but none as big as the one that formed the Moon. Molten rock or magma oozed in some places and blasted out in others. Volcanoes on the land and seafloor released heavier gases like carbon dioxide and methane. There was still very little oxygen in the atmosphere. The oldest sedimentary rocks found in Greenland tell us a lot about Earth during the Archean Eon. There were oceans, lands, rivers, and beaches. Deep in the ocean, chemical-rich hydrothermal venting may have contributed to the first forms of life on Earth. These first microbial organisms are thought to have eventually spread throughout the Earth's oceans. Some microbes consumed hydrogen gas and others produced methane as a waste product. Biology began to affect the atmosphere. By about 3.5 billion years ago, stromatolites, mounds made by microbes, populated the world's beaches. Some early microbes used the sun's energy for photosynthesis, but the first photosynthesizers didn't release oxygen. However, by 2.8 billion years ago, life forms evolved that could use sunlight to split water molecules and release oxygen as a waste product. These were the cyanobacteria that still prosper in today's oceans. Most of the new oxygen combined with organic carbon to recreate carbon dioxide molecules, and some was used up in other chemical reactions. But eventually, oxygen flooded the atmosphere and touched off a massive ecological disaster for many of the anaerobic life forms that were poisoned by the abundance of oxygen. Other life forms adapted to thrive in the new conditions. The rock record offers proof. Oxidized iron compounds are reddish and rust-colored. In certain layers of sedimentary rock, they demonstrate the predominance of oxygen after 2.4 billion years ago. At this time, oxygen formed the ozone layer about 20 to 30 kilometers above the ground, protecting life on the Earth's surface from the sun's harmful ultraviolet rays. The rise of oxygen was coupled with a reduction in greenhouse gases like methane and carbon dioxide. So the Earth retained less of the sun's heat, and the global climate became significantly colder. There was mass glaciation, and the Earth was encased in ice, often called a snowball Earth. The icy shell reflected sunlight, making it colder and colder. But volcanoes punched through the ice, and volcanic carbon dioxide gradually built up in the atmosphere. When the greenhouse effect became strong enough, the planet warmed, and the ice melted. Scientists think there were 3 or 4 huge glaciations over a period of time from 2.4 to 2.2 billion years ago, and then a period of about 1 billion years in which the atmosphere and climate were fairly stable. More recently, the planet experienced other snowball Earth events, but some life forms were able to survive the cold. The current Eon, the Phanerozoic, brought a proliferation of plant and animal life. Vascular plants with tissues for conducting water and nutrients colonized the land about 400 million years ago, and their photosynthesis caused oxygen levels in the atmosphere to rise. By about 300 million years ago, extensive forests covered the Earth. They pushed oxygen levels higher and enabled an even greater diversity of life. Biology, geology, astronomical events, and periodic variations in the Earth's position in orbit influenced the climate, but overall the atmosphere remained stable enough for life to persist.
These gases were lost and replaced by gases from volcanic eruptions, and oxygen from photosynthetic marine organisms accumulated in the atmosphere, and intense solar radiation converted some of it into ozone. Earth's atmosphere extends more than 1,000 kilometers above Earth's surface. Our weather takes place within the troposphere, a layer extending 12 kilometers above Earth's surface. In this layer, temperature decreases with altitude. Sometimes temperature increases with altitude. This is called a temperature inversion.
Visualizing the layers of the atmosphere. Earth's atmosphere is made up of 5 layers. Each layer is unique in composition and temperature. The layer you're most familiar with is the troposphere, the layer closest to Earth's surface. In the troposphere, the temperature decreases as altitude increases. When you fly in a plane, you might be flying at the top of the troposphere. Above the troposphere is the stratosphere. Air temperature increases with altitude here. Most of Earth's ozone layer is found in the stratosphere. Approximately 50 kilometers to 100 kilometers above Earth is the mesosphere. Like the troposphere, air temperature decreases with altitude. The thermosphere stretches between about 100 kilometers and 500 kilometers above Earth. Temperatures rise with altitude to more than 1,000 degrees Celsius. The outermost layer is the exosphere. In the exosphere, gas molecules can be exchanged between atmosphere and space. Dividing the troposphere, stratosphere, mesosphere, and thermosphere are areas called the tropopause, stratopause, and mesopause.
Right above the troposphere is the stratosphere, which includes our ozone layer. Here, temperature always increases with altitude, creating a permanent temperature inversion. The place where this temperature inversion begins is the tropopause, as mentioned in the video. The uppermost layers of the atmosphere, the mesosphere, the thermosphere, and the exosphere, are very low in density and do not affect our weather. The energy that heats the atmosphere comes from the sun. About 30% of this solar energy is reflected back into space by the atmosphere. About 20% is absorbed by our atmosphere. And about 50% of the solar energy is absorbed by Earth's surface. Trace gases such as CO2 and water vapor absorb infrared radiation and re-emit some of them back to Earth's surface. The greenhouse effect is a natural process in which certain gases in the atmosphere warm a planet as they absorb and emit infrared radiation. So let me just address a couple of things. Are we doing things to our environment that causes greenhouse? Yes, but without humans, without factories, without a ton of cows, we have a greenhouse effect that naturally occurs. It's what makes Earth Earth. It's what makes it livable. So greenhouse effect is a good thing. Speeding it up, not a good thing. Latent heat is heat energy released or absorbed during the phase changes of water, such as evaporating water or melting snow. Convection transfers thermal energy as warm and cold air move from place to place. If you'll remember on that second bullet point, the magma inside Earth, convection currents, or the hot cup of soup that we've discussed in class. Cloud formation is the first step in the precipitation process. The three basic cloud types are stratus, cumulus, and cirrus. Stratus clouds are layered, sheet-like clouds associated with rain. Cumulus clouds are puffy in shape and occur in fair weather. Cirrus clouds are wispy, high-altitude clouds. For precipitation to occur, droplets collide and combine. Precipitation, runoff, storage, and evaporation make up the global water cycle.
Energy from the sun causes water to change from a liquid to a gas by a process called evaporation. If water vapor in the atmosphere cools enough, it changes back into a liquid. This process of water vapor changing to a liquid is called condensation. Clouds form when condensation occurs high in the atmosphere. Clouds are made up of tiny water droplets that can collide to form larger drops. As the drops grow, they fall to Earth as precipitation, which completes the cycle by returning water to the hydrosphere.